right. Everyone can hear me? Perfect. Welcome to United Astronomy Clubs of New Jersey. Just to let you know, we are, in addition to having our program here on site in Jenny Jump State Park, we are also live streaming this on our YouTube. So if you're ever not able to make it, you can check us out on our YouTube page. And we also will keep the past broadcasts also on there. So you can always go back and view our previous uh, presentations. So a couple things to note. While I see a couple people are filing down from their cars in the rock, where you can see out over the distant hills. For our people online, you can check us out on our website at uacnj.org. That's where you will see a list of all our current programs available, as well as a list of all our member clubs and all our telescopes and any information you could ever want to know about us. And the information to contact us if there's not information you want to know, so that you can ask. You can also check us out through our social networks. We have Facebook, Instagram, Twitter. We also have our Discord channel. And I want to thank you all for coming, because we are a nonprofit, and all the work you see here has been brought to you by our volunteers who do not get paid, and because you guys have donated to keep us going throughout the years to offer these free public programs and outreach. So, since it looks like a lot of our people are starting to get in here, for the people here, if you need to use the restroom, that is our porta potty to the right, my right, your left. We also have a little gift shop and museum area that you can check out. Unfortunately, I am running the gift shop, so you might not be able to get anything there until I'm available after the stream. That being said, we do have, it looks like, at least one observatory open with telescope that we will be able to look through after our presentation tonight. Speaking of our presentation tonight, we have a good one with, what is it? Exploring the local supercluster. I nearly said the one you were originally going to give, which is why I needed to check. So our presenter tonight is Clif Ashcraft. Clif is a retired chemist who specialized in organic and polymer synthesis. He earned a PhD from Berkeley and a Bachelor of Science from the University of Cincinnati. He enjoys singing tenor with the Philharmonica, building telescopes, taking planetary images with a webcam, double star observation, and hanging out in his observatory with his guard dog, Chewy. Clif serves on the research committee of Amateur Astronomers Incorporated and, enjoys making presentations on a variety of astronomy topics. And with that, we're going to turn it over to Clif. And just to note, if you do have any questions, do save them for the end. We are going to do a Q&A session where I'll be able to bring the mic out so our online audience can also hear the questions you want to ask. And with that, Clif.
Okay. Can you hear me? Great, this thing is working. Okay, we're going to go on a journey today. I'm going to give you a little idea about the scale of things in the universe. Come on, let's go. I don't know why that's not advancing. There we go. We're going to be exploring our local supergalactic cluster. You may not realize it, but our galaxy, the Milky Way, is part of a small cluster of galaxies called the local group, and it's part of an even bigger group. But to give you a better idea of the scale, we're going to start way from the outside and then look into our local neighborhood. The big picture. This chart, can you folks see that? Okay. This chart was obtained by the Sloan Digital Sky Survey telescope down in Arizona, and it goes out to a distance of a redshift of about 0.12. That's a measure of how much the light has been redshifted by that part of the universe extending away from us. And what you're seeing there is a couple of 100 billion light years across piece of the universe. Now it's wedge shaped like that because you can't see the entire sky from Arizona. This is just a cross section of what you can see from Arizona. If you look at the very center part of that, here's a piece of the universe 2 billion light years across. This is our immediate neighborhood. Our local group, containing the Milky Way and a few other galaxies, is right in the center there. The Our solar system would be just the tiniest dot on that scale. You wouldn't even be able to see it with a microscope. It's so far away. Now, if you look at a smaller piece than the 200 million, this is the intersection of 4 of these strands in the cosmic web of our universe, where all of the matter seems to be concentrated and where all of the galaxies form, and of course the stars within the galaxy. And it's called Latakia, which means the a Hawaiian word meaning the immense heaven, and it contains several superclusters, 5 of them, including our own, and it's got about 100,000 galaxies in all in it, and it's 520 billion light years across. This is a big place, and this is essentially the state we live in. Now, it's got 5 clusters, 5 superclusters: the Virgo cluster, the Centaurus cluster, the Pavo Indus cluster, the Southern cluster, and the Hydra superclusters. And I'm only going to talk about one of them, our supercluster, the one that's named after the cluster, the Virgo cluster, which is in the constellation Virgo. That oval area, can you see that red oval? That's the size of our supercluster, and this is another view of it turned at right angles. And again, our local group is a little area down here. The Virgo cluster itself is way out here on the end of the supercluster, and there's some down here which are hard for me to see living in the northern hemisphere. It's about 120 billion light years across. And again, we're there. And I'm going to take you on a tour. You see those green dots appearing? These are places that I have taken images of galaxies. And it goes clear out to the Virgo cluster itself and a little bit beyond. You see that one dot there? That's as far as I've been able to see. That's 230 billion light years away. You know how far that is in miles? It's 1.4 billion trillion miles away. That's what 230 light years are. And I can see that from my backyard. These are the groups that are either nearby or the ones that are far out that I have explored. Uh-oh. Microsoft PowerPoint has encountered a problem and needs to close. We are sorry for the inconvenience. I'm very sorry also. Hang on. We'll get back there in a bit. Here we go. Okay. Okay. Well, the ones that are in light blue are the ones that I've actually been able to image. The ones that are white are ones that are targets that I haven't explored yet, and the ones that are sort of orange those I can't see from New Jersey, or our galaxy is in the way. Uh, Here's my spaceship. Oh no, that's not it. Uh, there's my spaceship. It's a 14-inch Schmidt-Cassegrain telescope and software that aligns and stacks short exposures and accumulates images that you can see in a rather quick fashion. And there actually might be somebody here tonight doing this sort of thing live on one of the telescopes, and you can see things this way in just a few minutes exposure that would take, you just can't see with the naked eye. Anyway, what I do is I hook up one of my little video cameras to the back of that 14-inch telescope with a device that makes it from f11 to f7, so I could get faster exposures. There's the focal reducer. There's my little camera. It takes a short movie, and the software processes it as it goes and stacks each frame on top of the other ones, lining up precisely. So it simulates taking a long exposure, doing very difficult guiding. So I don't have to do any guiding. The software does it for me. This is the procedure for live stacking with SharpCap, which you probably are not interested in since you don't have it. But here's a picture of the environment around our local group. The Milky Way galaxy is that one right there in the center, and the heavyweight in our galaxy is M31. That's up here. That's the galaxy in Andromeda. The M31 means it's number 31 on a list compiled by Charles Messier in France in the 1800s. He was a comet hunter, and every time he ran into an object in the sky that he thought was a comet that didn't turn out to be a comet later, he put it on his list of annoying things in the sky. And he's got, that list ended up with 109 objects on it. They were nuisances to him because they weren't comets, but they're very handy for astronomers to keep track of galaxies and star clusters and things of that sort. So M31 is the heavyweight of our local group. The Milky Way is the second biggest one. M33 is a little spiral galaxy off to the side of M31. And there's the Magellanic Clouds, the large and small one that you could only see if you're below the equator, and a bunch of tiny dwarf galaxies. That's our local group. It's about that big. And by the way, if Charles Messier had lived in the southern hemisphere, he probably would have decided that given this a Messier number 2, and it probably would have been included in the local group, but it's in the Sculptor group now. Now, I was in West Texas several years ago. You haven't seen the sky unless you've been to a dark, remote area like West Texas. That is our galaxy. That's the Milky Way. It was so bright there that if I put my hand over my white T-shirt, I could see the shadow of my hand in the light from the Milky Way, and we could barely see it in New Jersey at all. But we're seeing our galaxy from the inside out. Nobody's ever got outside of it to photograph it, but if they could, this is what it would look like. It's a barred spiral galaxy. There's a sort of a linear concentration of stuff in the middle. Our black hole is right here. I don't know if you've seen the pictures in the news in the last month. They've actually got a picture of that black hole, or the accretion disk around it, with the largest radio telescope in the world. It's actually the size of the world. And our black hole is right in there. Our solar system is out here. So this arm of the galaxy is between us and the central bar, so we can't see the central bar except a little bit above and below the plane of the galaxy. The Magellanic Clouds, the large one and the small one, are small barred spiral galaxies that are being tidally disrupted by the gravity of the Milky Way and will probably eventually be eaten by the Milky Way. Galaxies grow by absorbing smaller galaxies. So don't worry about it. We won't be here then, but when it happens, it'll be a fairly spectacular sky show, but the stars won't touch each other. They're too far apart. So nothing will likely collide with anything else except the gas and dust. This is Andromeda, M31. No, it isn't. Sorry. This is Andromeda, M31. It is 2.3 billion light years away, and it's neat to realize that when the light that left that galaxy that I took that picture with left, our entire family of genus Homo, the Neanderthals and all, we were just a gleam in the eye of a lovely Australopithecine Eve. We weren't here yet. You could call her grandma if you want. Here's M33, the pipsqueak of the group. It's a spiral galaxy, but not in the same class as either Andromeda or the Milky Way. I'm having trouble with this screen. Okay, we're going to go outside of our local group now. Now, here's a group called the Maffei group. Nobody knew about this group because the arm of the galaxy out towards the north, towards the constellation Cassiopeia, is in the way, and we can't see through it. But using infrared astronomy, they found that there is a barred spiral galaxy out there and an elliptical galaxy out there, and they're really quite close. They're the very next galaxies out from our own local group. Now, beyond that group is the M81 group, and it contains two large galaxies. This is M81 and M82, and this is sometimes called the cigar galaxy. This is a regular spiral galaxy, not a barred spiral like ours is, and this one is a starburst galaxy. It's having a large amount of star creation. It probably has an active galactic nucleus in the middle of it, and this looks very exciting in long exposure photographs in hydrogen alpha light. There's streamers above and below the plane of that galaxy. And this is only 11.4 billion light years away. Only. I mean, Andromeda is 2.3. That's 11.4. Here's the next further ones. That was the cluster and sculpture is 11.4 billion light years away. It's very similar to what the Maffei groups are. We can see these, but you have to go to the southern hemisphere. So that's not my picture. I got that online. Here's the Centaurus A cluster. Again, this is another one that is too far south for me to photograph. However, M83, which is part of the cluster that's in that, it occasionally gets high enough in the sky, I might be able to image it, but I got to catch it in a crack between the trees. The next group out is the Canis Venatici 1 group. They're 16 billion light years away. This one is very interesting in that it seems to only have normal luminous matter. It does not seem to have dark matter in it, and nobody knows why. It rotates just exactly like it should if what you see is what you get. Most galaxies have some dark matter in it, and they rotate the wrong way for what they rotate faster than they should if it were only the visible matter. Here is M101. It's 21 billion light years away out in the constellation Ursa Major. It is a very large galaxy, even though it's much further away. It looks about the same size as Andromeda in the sky. There are two small dwarf galaxies that are in this group with M101. Uh, uh, Here's one of my favorite galaxies. This is number 51 in Charles Messier's group of annoying objects. Uh, this is a beautiful spiral galaxy. It's sometimes called the Whirlpool Galaxy. And this, the bigger one is M51, and the small one at the top is called NGC 5912, and it's on a collision course with M51 and will really screw up that spiral structure, but it'll eventually be absorbed and become part of that galaxy. Something else happened to me on the night I did that. I was photobombed by Elon Musk. One of the Starlink satellites is a faint trace across right there. And I got a real surprise later. There is a, where did that go? Just a second. Yeah. Ah. Anyway, there's a faint object right, here it is, right here. That turns out to be a very distant galaxy. It's 230 billion light years away, completely outside of our supercluster. That's the furthest thing I have ever seen in my life. Also in that group, the M51 group, is this nice little galaxy here. They call that the Sunflower Galaxy, M63, because of its resemblance to a sunflower. Another group a little bit further away is the Canis Venatici group. It has a barred spiral galaxy in it. Looks kind of disrupted to me. And a group of 3 galaxies called the Leo 1 group. These are I hate that presenter's mode. I can't read it. 32 million light years away. The Leo 1 group has another nice barred spiral galaxy with both a ring and a bar in the middle of it. And the Leo 1 group has M96, and one of my other favorite galaxies, this one's called the Sombrero Galaxy because it kind of looks like a Mexican hat. 29 million light years away, and an interesting thing about this is if you look at it in infrared light, it turns into one of those ring things that you throw like a frisbee. The whole central dust is invisible in the infrared, and you only see the outer part of the galaxy. We're going to get some crazy views when the James Webb starts turning infrared images back for us. Other galaxies of the M104 group include this one and this one. And there's another popular group among amateurs called the Leo triplet. There are 2 of them fairly close together here. I was able to get all 3 of them at once by making 5 images of this area and putting them together in a mosaic. That's an edge-on spiral right there, and another couple of barred spiral galaxies. The Draco group is now getting very, very far away. This particular one is 50 billion light years away. It's an edge-on lenticular galaxy, and there's a dark line of dust going through here. You notice they're getting smaller because we're getting further away. This is a spectacular edge-on spiral. It's NGC 5907. Not a very fancy name, but that's the way we do it. The Coma 1 group has this galaxy, which is called the Needle Galaxy because it's so sharp. It's another edge-on spiral. It's probably a barred spiral like the Milky Way. This is what our galaxy would look like if you were on the outside looking through the plane of the galaxy. A couple more smaller galaxies in the Coma group. And now we get to the Virgo cluster, the heavyweight of our supercluster. All of those little dots are galaxies in the Virgo cluster, the heavyweight way out on the end of our supercluster. Odd thing about the Virgo group is that most of the large galaxies are elliptical galaxies. They're not spiral galaxies, and that means that in the crowded area of that very populated cluster, there have been a lot of collisions because eventually, after they collide enough, the spiral galaxies turn into elliptical galaxies and they don't form any more stars after that. They're basically red and dead, old red stars. Here's the 8 brightest galaxies in the Virgo cluster, and you notice that only 2 of them are spirals. The rest are elliptical galaxies. This is a pretty famous one. No, this one here, M87, and I'll tell you about that in a minute. Also, M60 is pretty famous because it has a companion, which is a small spiral galaxy in which there has been a supernova in the last few months. That dot right there, if I go back, it's not there. Now it's there. This is a star near the end of its life, a red giant that exploded and collapsed probably into a black hole. And so that's a supernova in the elliptical, near the elliptical galaxy M60. You may have seen the picture last year of the black hole in the middle of this particular galaxy. Here's a better picture of it that I took. That little thing coming out the side is a jet of matter going about 99.9% of the speed of light, being jetted out from the accretion disk around the black hole in the center of that galaxy. Here's the picture that the very large array of radio telescopes, an array the size of the Earth, took of the black hole in the center of that galaxy. It's way bigger than the one in our galaxy, but way further away. So it looks about the same size as ours, although it's really 1,000 times bigger. Further out, here's M100, the brightest spiral galaxy in the Virgo cluster. It's 55 billion light years away. And the Virgo 3 group is a small spur of galaxies off the side of the Virgo cluster, and they're mostly spiral galaxies. It's less populated in the Virgo cluster, so there hasn't been as many collisions. So most of them are still spiral galaxies. Another one way out on the extreme is the Ursa Major South group. Here's 3 galaxies in it. And the Ursa Major Cloud North group. And here is one of the nicest ones. This is M109 in Charles Messier's list. It's a barred spiral galaxy seen almost face on. This is a lot like the Milky Way looks from the outside. And with that, that's all, and I'll answer any questions that you have.
All right. Thank you, Cliff. Hold on. Oop, I'm just going to scoot on by here. Perfect. All right. So thank you for that tour of our local supercluster. I have been chatting online, but before we get into that, because I noticed a couple people who got in here a little late, if you guys need to use the restroom, it is the porta potty to my right, your left. Again, we have a gift shop and a little museum area open, and it looks like we even have a couple more telescopes open now that we will be able to look through after this. So how this is going to work for the question and answer session is, if when you have a question, raise your hand, leave it up, because sometimes in the process of navigating through the crowd, I lose you if you put your hand down. At that point, I'll hand you the mic and you'll be able to ask your question so our online audience can also hear, because chances are if you have that question, they also have that question or have a very similar question. So to start off, we're going to start off with an online question. And they asked, is this you had mentioned software earlier, the SharpCap
Yep.
software. Is the software you used free?
There is one version of it that's free, but live stacking does not work in the free version. You have to buy the pro version, but it's not very expensive. It's a very inexpensive program.
Do you happen to know about what it costs?
I think it was around $15.
Cool. Right. Is there a question out here? Bueller? Oh, did I see one out there? Ah, faking me out.
Hey, I've got a question for you guys. Are there any Trekkers in the audience? Any Star Trek fans? Well, at least one. Okay, you're a Star Trek fan. Yeah, I thought there was a whole bunch of them. Did you know that that there's a conversion between warp factor and the speed of light? And I looked it up, and Kirk's ship, the Enterprise, that could go warp 9.2, with 6 being the normal. If he put the hammer down and Scotty started complaining, he was going, let's see, you take the warp factor and raise it to the 10^3 power. And that means that he could go 1,632 times the speed of light. Einstein would complain about that. But it turns out that it would still take the Enterprise 22 hours to get from the Earth to the nearest star, and it would take him 1,555 years to get to the Andromeda Galaxy. M51 would take 14,191 years, and that what I showed you, M109, out in the Ursa Major North Cloud, it would take 49,000 years. So now you know why the writers never put any of their plot stories in other galaxies. Barring intervention or by Q or other higher beings, you just can't get out there with, only speeds like warp 9.
So our nearest star is Alpha Centauri, right?
Yeah, Proxima Centauri,
Proxima
which
Centauri.
orbits Alpha Centauri.
I was close.
Yeah.
So, that's like a cross-country trip across the U.S.
Yeah.
You could, I don't know, sounds doable to me, especially if I'm not driving.
Well, you can get to Alpha Centauri. They do everything in the Alpha and Beta quadrant fine, but you're not getting to another galaxy. Yeah.
Oh, all right.
Where would you recommend someone starts with this?
Where would
What's a good way to get into something like this?
Well, for one thing, visit UACNJ and look through telescopes, talk to astronomers. I started this when I was 3.5 years old. My mother let me stay up late to watch a lunar eclipse, right? So if you got kids, expose them to this stuff early. But there are people who get into it when they're adults, and join an astronomy club, talk to the amateur astronomers. You can even find people that'll show you how to build your own telescope. And they're relatively inexpensive online compared to some of the other stuff that we buy for ourselves. Yep.
Also, a follow-up to that is to get into astronomy, you might first want to narrow down what this is that you're exactly interested in, because there's many different forms that this hobby can take. There can be, you set up to do programs for the public. You can set up where you want to take the pictures. You can say, I want to be one of the people doing research. We have members who had worked to help discover exoplanets. So because astronomy is such a large field, pick a small chunk and work your way from there, is my advice. All right. So our next online question is, what is your favorite astrophotography target?
My favorite astrophotography target is the moon. I just love taking pictures of the moon, and they're all over my Facebook page. But the moon is great. I love the planets as well. I've got some great pictures of Mars and Jupiter on my website. By the way, if you want to look at my stuff, go to WA2GUF, my ham radio call, .org, and you can see all kind of stuff on my website. WA2GUF.org.
Hold on. WA2GUF.
UF.org. I guess the GUF is like for Chris Cali, guano underfoot. I was a farm boy.
Right.
Yeah.
Sorry, I figured I'd actually type that out for our
Okay.
chat.
Question back there.
Oh, okay. Hold on. Let me get you the microphone so our online audience can.
I think beginning of June 2nd, the weekend,
Yeah.
there's supposed to be a Milky Way, which apparently because of the weather, I missed that. When's the next one coming?
Were you talking about the
I-
meteor
I-
shower?
Yeah, I actually went to Spring Hill State
Yeah.
Park. Yeah.
Yeah, that was kind of a
Thank you.
disappointment. I observed it that night with my telescopes at home, and I was looking at just a small piece of the sky with a low power telescope, and over 3.5 hours before the clouds came in, I saw 33 satellite trails, 7 airplane trails, and 3 or 4 meteors, and only one of them was bright enough to be seen with the naked eye. The dependable meteor shower that's coming up near the end of July, the beginning of August, is the Perseid. But you got to go to a dark. But you went to a good site. I mean, Cherry Hill is one of the best places to go. It's nice up here too, but it's you don't really see showers in New Jersey because most of the members of the shower are very faint meteors that only show up in very dark skies. And you see occasionally the big bright ones. You see those, but the Perseids, those are pretty dependable.
I can also say there are websites. I believe Lonnie gave us one on his last presentation, seasky.org. If you look that up, they usually have a list of astronomical events so you can see like showers and like eclipses and transits. Right, so our next online question is, how do we know how far away these objects actually are, or these?
That's a very good question because you obviously can't take a tape measure out there and do it. There's a thing called the cosmic ladder, and it starts off in the solar system where you use methods of observation within the solar system to measure how far away the Earth is from the sun, the solar constant. That's your first step, okay? You know the distance between the Earth and the sun, and there's a number of ways you could do that. But let's say you already know that. Well, now, if you say look at the star field in the sky, and say January, and then 6 months later, when you're on the other side of the sun, you look at the same star field again. Now you're 2 times 93 million miles away from where you were before. You've got binocular vision. You look at those stars up there, and the close ones are shifted compared to the ones in the background, just like what happens if you do this with your eyes. And you can tell from that angle exactly how far away they are. Okay, there's 2 steps on the ladder. You know how big the solar system is. Now you can tell how close that the stars are. Well, some of the stars are variable stars called Cepheid variables, and they go up and down in brightness. If you can measure them by that parallax method, you know how far away they are. They correlated the brightness of those Cepheid variables with their period. So you measure their period, you know how bright they are, you know how bright they look, so you can calculate how far away they are. Now, There are Cepheid variables in other galaxies. There's some in Andromeda. And Hubble became famous because he measured the distance to the Cepheid variables in Andromeda. Therefore, you know how far away Andromeda was. Now, he screwed up the calculation. He had something wrong with they didn't understand exactly the period of the Cepheid variables then. But when that was all corrected, they figured out it was 2.3 billion light years away. So by then looking at galaxies further and further away, looking for their Cepheid variables, they discovered, Hubble discovered, actually somebody else discovered it and Hubble took the credit for it, that the further away they were by the Cepheid variable method, the more the spectral lines in their spectra were shifted towards the red. This is the Hubble constant. You could use the Hubble constant now to look way far away in the universe. It's something on the order of 60 megaparsecs per I forget the units. But anyway, if you look and see how much the spectral lines shift, you can tell how far away they are using the Hubble constant. So that's how they do it. And for even further away things, they use type 1A supernova explosions. You could see them clear across the universe, and you could calibrate the distance with those just like you do with the Cepheid variables. And that's how you know. Long-winded explanation, but that's the way it is.
All right. Was there another question out here? All right. So I'll get on to the next question in chat. How do you also define what a cluster's area is? So someone has decided that this cluster takes up this much space.
It's basically there's a bit of history involved, like when they discovered which one, and when they discovered how far away it was. But they tend to be in discrete groups in the sky, a whole bunch of them at about the same distance from our galaxy, and they are fairly close together. Now, you wouldn't put one that was 55 million light years away over there, and one that was 55 million light years over there in the same cluster. No, they're two different clusters. But that's how. It's not very scientific, and they're probably not gravitationally bound to each other either.
So much like how borders of countries and international waters were decided.
Yeah.
Yeah, that kind of looks about right.
Yeah. There's not much physics involved in that. It's just like keeping catalogs.
All right. Questions? All right. So, spin-off of the astrophotography question from earlier, Paul has seen some of your varied images on Facebook. How would you rate galaxies as favorite target to image? So, pick 5. What's your favorite? What's your least favorite?
Of the galaxies that I've looked at?
Yes.
Well, I think my absolute most favorite one is M51. I really like that one. That's kind of cool. And I like M109 because it's a neat galaxy and it's very far away. So, but I really like the Milky Way too, though, because it's home.
All right. Anything else? If not, I'm just putting out a last call for any questions online, just to give them a couple extra seconds. I want to thank you all for showing up. I know a couple of you are very antsy because it's a bit cooler than it has been lately, because it's been lovely and in the 80s, and right now with the breeze, I don't know what the temperature actually is, but I've become that person who walks across the snow-covered ground in shorts and flip-flops. But it looks like questions are it. I want to thank you, Cliff. And again, we'll see you next time. Be sure to check out our next presentation. And even if you can't come, you can check us out online. And have a good night.